We're trying to solve a linear congruence with a 3-digit modulus. Now, you could try all 341 remainders and one by one go through it like that. That is a possibility, but you can see that the small numbers don't work. So we're looking for a tool that will help us here, and that's the Euler Phi function. Now, this result is something that gets shown quite a bit in number theory, but what it says is that a to raised to the phi of b. Now, y'all, phi just counts the number of relatively prime values less than b, but this is congruent to 1 mod b. You know, that is a b there, modulo b. Now, it's not so important what phi does. I mean, this property is important, but like, for example, phi at 6 is 2 because only 1 and 5 are relatively prime to 6. Okay, but we don't really have to be that aware of that as far as utilizing this result. So it says, this says that a raised to the phi of b is the same as 1 modulo b. And of course, we have to assume that a and b are coprime. So right over here, I'll say AB coprime, or relatively prime. All right. Now, this result, the fact that this is equal to 1 modulo B, is why this is true right here. Notice that this is just a to the first power. So if you multiply through by this, you see how we get cancellation on this side. Okay? The x will go away if you multiply through by this object. See, this will give you a to the phi of b on this side, but that is just equal to 1, right? So you see this would actually just become 1 right here. The 1 that you see right here is from this, okay? When you multiply through by this, okay, laws of exponents, and we're actually multiplying through by this object right here, okay? If you multiply through by this object right here, phi of b minus 1, okay, these 1s go away and you would have a to the phi of b, period. But that's congruent to 1 that you see right here. So you see, this gives you a solution. So if you can calculate phi of b and subtract 1 and raise a to that power, okay, and then multiply by c and reduce it modulo b, you'll have a solution. Okay, so let's see how that goes. All right, so here's the original problem. 7x is congruent to 12 mod 341. Now, here's our result right here. We're just using this fact that hopefully I made sense when I explained why it's true. All right, so we get this statement right here. Now, a simple, it's fairly easy to compute phi at 341. Doing it directly, of course, is a pain, but there's a nice result that says all you have to do is know the prime factors, essentially, and take their reciprocals. So this is actually equal to 341 times. Now, what I'm going to write down here, folks, is the reciprocals of the prime factors of 341. They happen to be 11 and 31. Okay, and so what you get right here is this. And y'all, this is a result I'm not going to prove, but it's a standard result that it's either proven in the section or it's a homework exercise, but like this. Right? Okay, so you can see this would be 10 over 11 right here. This would be 30 over 31, and you would get 10 times 30, which is it's 300, and then you have to subtract 1. That's where this 299 comes from. Okay, so let me write this down right here. This is equal to 300. And it's not hard to see, folks, because, again, 11 times 31 is 341. 1 minus 1 11th is 10 over 11. 1 minus 1 over 31 is 30 over 31. And 30 times 10 is 300. The 11 times 31 is 341, right? Okay. Now, but notice you have to subtract 1 based on this result right here. You have to subtract 1. And so you get this statement right here. It's 12 times 7 raised to the 299th power. Now, that looks very, very oppressive, but it turns out there's a super, super useful result. Let me write this here. 7 cubed is actually congruent to 2. All right, it's congruent to 2 mod 341. And y'all, that's not too hard to see. It basically 7 cubed is 343, right? 7 times 7 is 49. 7 times 49 is 343. Minus 2 is the 341 that you see right here. Okay, so you see that this is congruent to 2, but that's exactly this 2 right here. 7 cubed is the same as 2 modulo 341. Okay. Okay, so we got that far. Now notice what happened right here. This piece right here, we get 12 is also 3 times 2 squared, right? Okay, and so here we go. We got 2 squared. Now, what about the 2 to the 10th? Okay, the 2 to the 10th. Okay, why did we even consider that? Well, 2 to the 10th, okay, let me just write this right over here. 2 to the 10th is congruent to 1. Okay, now y'all, 2 to the 10th is 1,024. 1,024 minus 1 is 1,023, and 3 times 341 is 1,023. Okay, so that's why we could replace this 2. In other words, this is just laws of exponents right here, right, folks? In other words, 299 299 is equal to 3 times 99 plus 2, right? Hope I'm not clearing this up too much. Okay, so that's what happened right here. And so we use the fact that we have 7 cubed is actually congruent to 2 mod 341. And then we get this statement right here based on 2 to the 10th being congruent to 1 341. Okay. All right, so that's how all of this happened up to here. Now, and you can see right here the 2 to the 10th becomes 1. Okay, 2 to the 10th becomes 1. And so all of a sudden this becomes fairly simple. All right, you just end up with this statement right here. 2 to the 9th times 2 squared is 2 to the 11th. All right, but remember 2 to the 10th is congruent to 1. So that's why we only have, this just becomes, this part right here just becomes 2. And I left that out, but that's because 2 to the 10th is 1 modulo 341. Okay. All right. So hopefully that all made sense. It's just kind of some grinding out arithmetic. And you'll notice that this result here, 6 times 49 is 240 plus 54. That's 294. Okay. So 294 is our answer. Okay. And I do want to stress that you had the option to check all of these, but you could see it would be very, very tedious. You could go 7, obviously the single digits don't work. You'd have to get up to around 50 something before you'd have to worry about a 3-digit number making an appearance, right? For example, 7 times 50 is 350 minus 12 is 338, not a multiple of 341, right? So you have to get up to some fairly large numbers, but it's still a lot of checking. Theoretically, you can do it that way, okay? But it's just very time consuming. And you wouldn't even know, it's so easy to make mistakes. This is, I would call this rather tedious, and it depends on a couple of lucky facts, namely 2 to the 10th is congruent to 1, and 7 cubed is congruent to 2, all mod 341. And that simplifies the computations immensely. Had this product here been a number bigger than 341, we would just have to divide it by 341 and write down the remainder right here, okay? But a number is congruent to itself. So this is the solution. That's all. Till next time.